Hello, I'm Chris OldWood, and I'm here to talk about branching amongst a number of other things. We're going to take in a little bit of tiny bit of history, a bit of risk management, and some other kind of software development practices and stuff. Next one as well, kind of along the way. I kind of gave a talk around version control patterns and practices when we first came to Bristol a few years ago. So you might see a couple of slides in there that look vaguely familiar. But kind of hopefully what I've done is I've kind of shaped it around looking at it branching from a different perspective. That was more about kind of mechanics and stuff, and hopefully there's a little bit more kind of around philosophy and stuff, because it's quite a emotive subject, and there seems to be, different people have different views and stuff, and we're kind of like look maybe a bit more behind what we're doing there. Okay. So. Back in 2000-ish, Steve McConnell, who of Code Complete and Rapid Application Development fame, coined this term cargo cult software engineering in an article he wrote for IEEE software. And the term, obviously, cargo cult itself comes from, it's quite an old sort of established term. Most people kind of know of during the Second World War, the Melanesian Islanders around, which is sort of off the coast of Australia and Papua New Guinea and Solomon Islands. There were various people stationed there, troops stationed there during the Second World War, such as the Japanese were there and then the Americans. And they were quite a sort of a primitive culture, and they suddenly came into contact with these sort of more modern civilizations, and suddenly became accustomed to the resources that kind of came about. They were clothes and food and troops and machinery and planes and stuff. And then sort of unfortunately for them, although obviously fortunately for us, the war kind of ended. And then obviously all the troops and everything left, and they're kind of like left back where they were. So they kind of like obviously wanted to get back to kind of where they'd been because they were enjoying it. So they started trying to do what they thought the sort of troops were doing to attract planes and stuff to land again, and hopefully to kind of get their hand on the kind of resources. So they did things like they built fake runways, and then they built I think there's some pictures of some balsa wood planes, and they lit fires on runways, all are kind of like in the hope that these were the things that they'd seen the troops doing to attract planes, and they thought that by doing them themselves that things would happen. So they're effectively mimicking behaviours without understanding. And this is what sort of McConnell kind of was getting at, was he started to see organisations doing the same kind of thing. They were looking at other organisations they aspired to, and effectively thought that by copying the practices that they were doing, that they would be like them themselves. In sort of nowadays, I guess they'd be, this is back in 2000, so I guess now the likes of Google and GitHub, and probably even some degree even in some of the stuff that Microsoft are doing and other companies, are seen as kind of quite aspirational companies. So they're looking to take on those things and hoping to sort of become like them by following things. But they don't understand the values and principles necessarily behind the reasons why those companies are doing what they are. And I think it's quite easy to see why this kind of thing has happened. So this is Jez Humble, who wrote Continuous Delivery with Dave Farley. So, he's kind of like a bit of a luminary in the software development world. And he tweeted this slide from some Google presentation. And if we kind of like look at some of the things that are on here about what Google do, who wouldn't want this kind of behaviour in their own organisation? So they've got 10,000 developers. Wow, this is like a massive company. There's lots of people, lots of developers churning out code. This all sounds good. If their massive company can do it, surely our 3-person team or our 10-person team would be a doddle. 2,000 projects on the go. Yeah, loads of work, and yet they seem to manage to make this work. Single monolithic code tree, so this mono repo is another thing that's kind of sort of picked up in time. People deciding to sort of stick all their eggs in one basket rather than maybe having different repositories. So kind of again, if Google can make this work with 10,000 developers, should be easy for us. This next one, 20 plus code changes submitted per minute. So that's like 1 every 3 seconds, up to 1 per second. So that's a huge kind of rate of change. I think recently somebody tweeted that they actually pushed to production once every 12 seconds. So again, who wouldn't want that, features delivered to their customers at such a phenomenal speed? 50% of code changes every month. So big investment in kind of refactoring and keeping the design, keeping the code malleable. So not even, just potentially even delivering new features, but keeping other stuff going. And this one is perhaps most pertinent to what we're doing or what I'll be talking about later. Everyone develops and releases from head, so they effectively use a single, no branching, everything's thrown into one branch, and that's kind of where their code's delivered from. And finally, all builds from source, so they don't kind of cache things, they build everything from scratch. So, great, who wouldn't want this kind of stuff? But I left something off the bottom. I mean, if you're going to copy something else, you don't actually read to the end of what you copy. You just take the bits you're interested in and go, yeah, that's good for us. But right at the very end, at the bottom of this slide, 100 million test cases. So effectively to support the kind of development process that they're kind of putting in place, to support this ability to develop from head and stuff, they have, a huge investment in testing. And obviously what comes with that, you can't just run 100 million test cases on your machine. You've got to have a massive infrastructure. And not only that, but you're going to have smart people to kind of to develop this stuff. They have the money and they obviously have the resources, I guess the kudos to attract the kind of people. And they're probably well outside of the tooling that most of us use. So they have the ability to deal with the issues that will come up with that kind of scale. So yeah, it's kind of, again, this is probably sort of the most important thing that kind of sort of backs what they do. So if you're wondering about the title, there's a book, I kind of read this quite recently, by Tom DeMarco and Tim Lister, called Waltzing with Bears. Those of you who were at the Barcello, when we were at the Barcello a few years ago, Tim Lister actually came and did a keynote. He's got another book around adrenaline junkies and template zombies, and he did some of his patterns like dead fish and that kind of stuff, which is really good. And it's a really, really interesting bloke to talk to if you ever get a chance. I think we kept him in the bar for a good couple of hours, checked him. But anyway, him and Tom DeMarco wrote this book. It's actually about managing risk on software projects. But the title from this book, Waltzing with Bears, comes from a Dr. Seuss song about his uncle who waltzes with bears. And as a big kind of fan of Dr. Seuss, I like, I often read bedtime stories and stuff. It was only whilst recently reading a couple of things, I read Fox and Sox, that it kind of became apparent that I think that maybe Dr. Seuss, some of Dr. Seuss's work might have come out of merge conflicts. Anybody who's had to sort of deal with, a Tweedle Beetle Battleman Moodle Eatling Noodles is kind of the kind of semantic, that's the kind of spaghetti code and stuff we have to make sense of. Anyway, so back to the book. So it's a book about risk management, and although I'm a kind of like a developer, I'm kind of beginning to sort of try and get a feel for some of the other stuff that kind of happens around me. And Seb Rose referenced this book a few times in the past. It's only about 200 pages long, it's quite an easy kind of read. But it kind of like came up sort of again and again around kind of the sort of the ideas around it, and so I thought I'd kind of skip through it. And effectively the kind of like subtitle is that for project managers, risk management is project management for adults. The book sort of starts with a kind of a little sort of a story around, or an incident that happened in London in kind of the, I think it was sort of late 19th century. There was a meeting of the Metaphysics Society, which I think we'd call a philosophy meetup if it was kind of like hip and trendy today. And anyway, there's like lots of kind of like, important kind of philosophers and that kind of people there. And a guy called William Kingdon Clifford had a paper that he presented called The Ethics of Belief. And at the time, there was a sort of, it was deemed that you could believe what you wanted to, that effectively anything, your actions that you did around your beliefs didn't necessarily have to kind of, relate it. There was no, you couldn't believe something and that to be unethical. And Clifford basically challenged this with a little tale around a ship owner who had an emigrant ship. And this ship was a bit kind of old and rusty, and obviously, with the high seas and stuff. And he had to make one more journey. And he decided that, he sort of went, well, I know the ship's quite old and it's, a bit rockety and stuff, but, we've made it in the past, and so we should quite have, why don't we do it? One more voyage, it's kind of, we can make it. And naturally, of course, during a storm, the ship's lost, everybody dies, unfortunately. And naturally, everybody kind of like agrees, that was wrong. I mean, why did he take that risk? It was ridiculous, He knew the boat wasn't really seaworthy. So, it was definitely kind of the wrong thing to do. And then he kind of repeated the story, and this time he kind of changed the engine and said, why do you, this time, the ship gets to the other side, everybody kind of lives, and, all good stuff. But fundamentally, he said the only difference between those two things was that in the second case, he wasn't found out. He still had no more right to believe that his ship was seaworthy than it was in the other case. And quite a lot of people get upset about this idea, and, I think the secretary resigned and various other things kind of happened. And that kind of leads to one of the first kind of quotes, I guess, out of the book, which I found quite interesting. And this is the idea that the business of believing only what you have the right to believe is called risk management. It's kind of a bit of a philosophy, kind of like a philosophical kind of side to risk management. And I think it ties in quite nicely with the whole cargo cult mentality, this idea of just adopting practices just because we see people do them, but we don't have any basis in picking and choosing the practices that we use. We should have something there. And so, although it's a bit philosophical, there's this sort of, Dave Farley talks a lot about the scientific method, and many other people as well, but within the sort of continuous delivery world, that's becoming a big thing again, that, we can't idly do things, we need to do stuff, and we need to have some basis behind them. So, Tom Gill, for instance, he's a classic person who loves to quantify everything. He can quantify music and love, if you've ever seen that. That's kind of amazing. So, as I say, it might be kind of a sort of a philosophical aspect, but effectively it leads to us wanting to do more, to understand more about why we make the choices we kind of make. So kind of like taking the risk management side of things a little bit further in the book, it talks about risk management as the process of thinking out corrective actions before a problem occurs, i.e. while it's still in abstraction. So as a program, it's got the word abstraction in. Everybody loves abstraction, so that kind of, I thought, why not? What we're talking about here is, rather than talking about particular incidents and things that might happen, specifics, there's a fire in the building, we lose our data server, or something else happens and the hard disk fails. We're trying to think about risks in a sort of a slightly more abstract, a slightly sort of bigger sense, and try and sort of group those things together. And I guess anybody who's worked on software projects for more than a few years, you'll have plenty of horror stories around things that we tried to do, things that creeped out into production, stuff that failed, things that we missed, that kind of stuff. And so this is kind of like looking at, maybe categorizing at a bigger level some of those things that happen in software development in a kind of like a more abstract sense. And I've picked the two that I think are kind of most pertinent. And the first one is loss of productivity. So we perceive that, one of the reasons why we might choose, say, particular branching models and stuff we'll come on to, is around that idea of, what happens if somebody breaks the build? So it might just be a case of, I forgot to check the header file in. Oh, good. Maybe the guy opposite, or the girl opposite, they've gone to lunch, and they forgot to check something in, or maybe they broke something. We'll fix it kind of after lunch. Maybe, though, and this has happened, certainly to a team I've worked in, somebody decides they're going on holiday for 2 weeks. It's Friday afternoon. It's about 5 o'clock. I want to get away. I don't really want to leave the code on my desktop because somebody might move it, break it, so I'll just check everything in, and then I'll go away for 2 weeks. But of course, this is in an era long before the days of Slack or whatever else, so there's no way of getting hold of them. They've got no remote access. Lo and behold, you come in Monday morning and you find that nothing compiles, nothing works. And you've got to sit there and pick the bones out of it. Maybe you have to wind back their changes, or maybe you've got to hack into their machine and try and commit the rest of the code they forgot. I know, but you're at least going to spend time wondering what on earth to do about it. But it's not just about sort of developers either. There's a kind of a knock-on effect. So the development team might suddenly stall because it's kind of a compilation problem, but maybe it's something a bit bigger than that. And then there's other people involved in the pipeline. There's testers. I've seen cases where somebody will be working on page 10 of, say, a web journey, and because they're a developer, they know how to skip the first 9 pages, and they'll test it, and they'll commit it. And then it goes to the tester, and the first thing the tester does is open the home page. The page doesn't even open. They can't even test anything. So all of a sudden, we kind of go around the loop again. Or maybe, the deployment's broken. Something about either the machines or the configuration. Somebody's gone and updated all the NuGet packages, but they haven't added the extra kind of assemblies or something in, or they haven't changed the version numbers and assemblies, and therefore it won't deploy. So again, the testing team or whoever else it is that's involved in it, they can't do that. So, there's a very real kind of sort of, downing of tools or kind of like dealing with issues. And even deciding what we're going to do. Are we going to move forward? Are we going to roll back? It's all kind of like time. So maybe we're kind of like thinking, no, actually, this isn't a good way to be. Maybe we need to find other ways to deal with that. And so the second kind of like abstract thing, that's about kind of practice. And this is more about sort of, again, it's more about the, the code itself. How confident are we about the changes that we're making? Can I change one bit of code without affecting something else on the other side? So, how well the design is, how malleable it is. But usually it's not really about the code, is it? It's more about the people. It's actually how much confidence do we have in the people. Maybe we're a team of 10 highly skilled engineers, which is great, and we all kind of know the code inside out. We've been working here for years. Or maybe it's 10 interns or a bunch of other people that are involved in it. And so we're kind of like, they're quite new, and we really don't want them just like hacking around and doing things willy-nilly. So, maybe actually what we're less confident in is their ability to, A, actually deliver the thing that the customer wants, and to be able to do it in a way that doesn't introduce any weird performance or other side effects, that they're not going to do something that's going to break, say, other parts of the pipeline, or it's going to disrupt, other people. So maybe it's about kind of like people. So the last bit I kind of want to touch on is the finishing off the kind of bit about risk management. And that is when we sat down and we thought through the kind of like the risks and stuff that we were involved in on a project, thinking about what we're going to do about it. How are we going to deal with it? How are we, or not deal with it, essentially. And in the book, they talk about there's these 4 ways of kind of approaching it. And I think the first one's quite interesting, because I'd obviously seen risk management as a sort of in a pejorative sense. It always seems to be about kind of like the negative connotations. It's always about bad things that are going to happen. Server's going to catch fire, data center's going to go up. It's that kind of thing. But actually, the first one they talk about is sort of almost the opposite of that, which is to say, one way to not have any problems is to not do it. So let's not build this product, let's not build this feature, let's not do that project. But there's inherently a risk within doing that, and that is that there is effectively a lost opportunity. We might not, there might be an opportunity in the marketplace for us to do something. It could just be a feature or a whole product. And therefore, by not doing it, we don't get to exploit that. The book talks about Fidelity and Merrill Lynch as being an example of this in the 90s, where one decided to embrace the unknown and dive out there and do some online banking, and they didn't know anything about security and building web services and that kind of stuff. And the other, I think it's Merrill Lynch, decided not to. They kind of like sat there. And as a consequence, one of them ended up growing massively in that time, and the other one kind of sort of stagnated. But more recent kind of example, I think, of this is looking at companies like Netflix. This idea, if you're aware of the idea of the Simiamani stuff they're building, it's like the Chaos Monkey, which is a tool that runs around killing production servers or effectively creates, disrupts kind of production. So rather than sort of sitting there and thinking about, rather than trying to theorize what happens when our system fails, they decided, well, I don't know, let's just go and find out, for instance. If we think that we can actually deal with these issues, and we have to deal with these issues, and we'll get better at it, let's go and do it. It is a risk, but there's an opportunity there. And that opportunity is that we absolutely know that when servers go down, our customers aren't affected. So they're kind of like, there was an opportunity risk, and they kind of took it to learn more about the system. They did. So that's kind of avoiding it is a different kind of thing. Secondly is containment. That's about when a risk materializes, you're into crisis management, and therefore you're kind of dealing with the fallout. This is our broken build, or massive sudden bug lists, work going back through the pipeline again and again. Or in the case of sort of database, we've lost the whole thing. How the hell do we reconstruct that? Contain it, but that tends to be quite a costly exercise in time and money. So closely related to that is this idea of kind of mitigating it, which is to do something so that when the risk does materialize and it doesn't go away, how do we kind of deal with that problem? How do we reduce the cost of having to deal with the fact that, I don't know, bugs, what happens? How quickly can we get back around the pipeline? How quickly can we fix things and make things kind of move on? And the last one, they come up with this idea of evading it, which is basically crossing your fingers and saying, you know, la 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 la, nothing's ever going to happen. We'll never have any bugs. You know, we'll never have a failed deployment. We'll never have to roll back. We'll just kind of, you know, we'll just carry on blindly and hope that kind of nothing happens. So, done a little bit of waltzing, kind of like maybe we'll do a bit more kind of branching. So, next part, kind of when I want to talk through branching strategies. And hopefully you kind of, the bit that I've sort of gone through first of all, hopefully you'll kind of have that in your mind. The idea is for you to have that kind of thing in your mind. Think about, you know, the techniques and stuff that we're presenting, or the ideas we're presenting, but think about them in a maybe in a slightly different way. Thinking about maybe how to actually deal with this in a different kind of way. So branching. It's quite an emotive subject. There's quite a lot written about how you should do it, how you shouldn't do it, when you should do it. Unfortunately, it's as tools have got better, it's become easier to do and cheaper to do. So, you know, it's easier when we suddenly decide that it's time to sort of create a new branch or work in a different way or push things to one side. Because they tend to work on immutable data structures, they use this idea of persistent trees or persistent lists, and it's quite easy to add new commits on. Branching is a really, really cheap kind of thing to do. You can just spin them up just like that. In deciding when to do it, though, it's maybe a slightly different, you know, it's more of a complex, potentially more of a complex decision. There's an old book called SCM Patterns, which I've got a copy of with me, which is a very old book from sort of early 2000. And in there, they talk about the idea of code lines, sets of revisions, and they talk about having different branches having different policies, which kind of like sounds a bit sort of fancy. But really, what they're talking about is there's different constraints. And the idea back then was that if you had a change, you had a set of revisions, and then you had to make another change, then basically if the set of constraints were the same, you could make it on that branch, and if it turns out those set of constraints were different, either because of people, process, whatever, then effectively you created a branch. So branching was kind of all about creating constraints around things as a kind of a reaction to kind of what's happening. But sort of, you know, tooling and stuff has changed a bit. But of course, it's slightly ironic that we talk about branching when branching is the easy bit, and the problem, of course, is in merging. We should really be talking about merging strategies, because what we're really talking about is how do we deal with the fact that we're suddenly throwing together code from different parts? How do we resolve that? And whereas we branch at the start of a project, or we branch very early on, when we know least about the problem and we've developed the least amount of code, we merge presumably quite late in the day, the time at which time is now of the essence, the customer's jumping up and down, we need to get something out the door, and so it's kind of a bit, it's not real, all our pain is kind of like stored up to the end. If we're unproductive or you know, with people, that just kind of exacerbates the problem. There's in recent years as well, there's somebody's borrowed the technical debt metaphor, and they've come up with this idea of merge debt, which is kind of is almost as your changes live for longer and longer without you integrating anywhere, you're effectively storing up merge debt, you're storing up pain, which is only going to come back and bite you. So you might kind of hear that term, which is kind of again, it's a nice sort of similar metaphor. That's Clapham Junction, which is where Russell Wind lives, so I'm sure he'd appreciate that. Right. Okay, so kind of back in the dim and distant past, before tools and things kind of generally supported branching, we only had one. That was kind of generally the way it worked. You developed on your machine, and you kind of, you know, you sort of threw things together into a single integration branch or development branch, as it was called, and that's effectively how you kind of worked. Just to kind of keep people on their toes, people like to call this by different names, so it's trunk or master or main. You know, we can't even agree on a nice bit of terminology. Fundamentally, it's kind of it's sort of development branch has kind of settled down a bit. I mean, really, from a collaboration perspective, there are really only two sorts of branch. You are either collaborating with a bunch of people, i.e. an integration branch, or you're in your own little sandpit, in your own little world, doing your own little thing, in which case that's private. And that's kind of all there is. everything, and then many other kind of variations on that. And the 3 patterns we'll kind of describe, look at it, take it from a more sort of risk kind of perspective. But effectively, this is kind of where we are. One large organisation I worked at used to, within a big team of sort of 50 to 100 people, they would have one of these per project as well. So on top of your main development branch, there'd be one of these per project. We were going constantly merging to and fro, and then each of those would have their own private branches spun off of that and feature branches, and yeah, like the tree that we saw earlier, the banyan tree, which is, huge kind of like sprawling mess. That's pretty much kind of how they work. So that's kind of a classic anti-pattern that you often see around sort of big organisations when they're unsure about deliveries and projects and how things will kind of interplay. But anyway, this is kind of how we used to be. So the most common kind of alternative is, we were quite happily delivering features. You get to version 1.0, and all of a sudden, we suddenly kind of decide that actually we don't want other people throwing in kind of changes for version 2, version 3 at the same time. What we really want is to kind of like stabilize. So what they used to do is a thing called a code freeze. And I think I know at least one person in ACCU who still works with a code freeze kind of mentality where effectively everything stops and there's a few people who kind of work in isolation and they smooth over the cracks and kind of patch things up and do very sort of very kind of like surgical kind of changes, and they deliver those. And meanwhile, everybody else has to find out something else to do, like read documentation or, write documentation or write code and use zip files or whatever. Find some other way of working without having to basically commit. So the release branch is a classic way of kind of dealing with that noise that effectively sits outside the team. And the team kind of version 1, at some suitable point in time, you kind of like spin off a branch. There's a load of kind of like stabilizing work that happens there, probably, small changes. Meanwhile, everybody else gets to soldier on version 2 of the project working in the background. It's a classic kind of pattern. And then maybe at the end of it, we'll kind of like merge in those like little fixes and things that happened as we went along. We can do it as we go along. We don't really know. From a risk perspective, it's nice and stable. Changes are quite minimal, don't pull too much in. So it's kind of like there's a flow from kind of the stable to the more volatile kind of works. Other reasons why this is still kind of a prominent pattern is if you work in an organisation with either a change control board, who kind of probably meet once every 3 months, and so you're kind of sitting there trying to decide what to do, where you can't change things because effectively they have to have sign-off releases, that kind of stuff. Or if you work in an environment maybe with regulatory stuff and the rest of the organisation is kind of, again, you sort of have to kind of create a fixed point in time that you can deliver and sign off, and you don't really want to wait for this one to go into production while it's sat in UAT and you want to carry on. Still a kind of a similar kind of thing. So that's, that's quite a common oops. The other reason is anybody who works in an environment where you have multiple products, something like Anna Jane, for instance, so where they have many versions of Visual Lint, I'm sure you have to support customers who are on umpteen different versions, and when a particular fix goes in, I guess they're not too happy about being told they have to upgrade to version 10 just because of some minor thing that doesn't work in version 2, and so you have to deal with the fact that you want to make a very, very, very specific kind of change to a product. In which case, you've got some version base, some point in your history, and as a consequence, you're going to need to do some work. So a release branch is cut from that label, so you know that it's literally just that version plus your changes. And your confidence is that you're kind of buying confidence by assuming that whatever else you do here, maybe you can, should we say, shortcut certain things and testing or something too, because you're reasonably confident about the way you sort of left things. So that's kind of a way of trying to buy yourself potentially some confidence, or at least minimise the impact within changes. That's branching. And again, you would kind of like merge back, or you might merge to various other versions of the product and check and change those. But that's another reason why it kind of comes in, to make specific changes to older code. So something that kind of gets very bad press, and probably rightly so, is the idea of cherry-picking changes. This is where perhaps we're working on a release branch and we're kind of like trying to stabilize, get another version of the product out, or trying to do another iteration of our product. Meanwhile, in the background, somebody's added or they fixed something in the background, but for whatever reason, the product owner hasn't pulled it into the next release. And what happens is, it's a bit like, and then all of a sudden maybe you've been held up, and then all of a sudden you decide that they really want this now, and so somehow we have to find a way of picking the bit out of this that we need kind of into our release project. But the problem is that often comes with dependencies. A development branch, by definition, is quite a volatile place. Probably doing some refactoring, we're changing dependencies. I mean, who knows what else we showed. And it's a bit like pulling the thread on a jumper. You kind of like start with a bit, and then you pull a bit more and a bit more and a bit more. Before you know it, you've taken pretty much an arm and the collar with you into it. And now to get the one line of code in here, perhaps in here, you've got to take a whole load of refactoring. And of course, that's kind of adding a whole load of testing burden to you. And again, we're into the lack of confidence because you don't know what other kind of effects and things have come in. Often it's more of an organisation. The reasons for doing it tend to be kind of more because there are organisation problems that sit around inside you. Again, change control board, you know, they haven't met 2 weeks. Now all of a sudden that slightly urgent performance fix is now really urgent because they're holding us up, and therefore we end up sucking in more and more change to compensate for the fact that they're kind of like slow to get things through. So if we think of our kind of main line as being sort of the equator, and then sort of release lamps as being our sort of north pole, then I guess we have our kind of our task or feature branch or various other names it goes by, private branch, as being the sort of the polar opposite of that. Whereas the other one tends to be about stability and protecting the product, this tends to be more, we tend to think of this more about being about change that's very risky, tends to be quite volatile, and so we sort of view it more as about changes where we're almost protecting the sanity of these people or the work that they're trying to deliver that next product. So a common use for that is things around, so spikes, for instance, is a common reason to do that, or I don't know, you're going to change something that will involve a massive amount of refactoring, you want to try things out. But again, it's kind of not necessarily the change. Maybe it's about the people again. Maybe we look at the people and think, well, actually, you know I've given this task to the intern. I don't really know what they're doing. I don't really want them making a big sort of mess of what happens up here again. We kind of fear the loss of productivity, and so we're kind of thinking, well, we'll keep them off to one side. Somebody will keep an eye on them, and hopefully, you know, when we kind of get to the end, we'll deal with that kind of sort of fallout later. Spikes is particularly good for because they tend to be, you know, even in some of the other sort of things that we'll show you or we move on to in a minute, feature branches are still good for a spike because they tend to be about knowledge. They tend to be about trying something out. And although you could pull the code over at the end of it, really what you tend to be concentrating more in the learning. You might be hacking around quite substantially as you do that. And if you bring all of that in as well, you create an awful lot of noise in the history, which, you know, can be quite important. So sometimes we think, well, we've gained the knowledge into this way. What we really want to do is just throw away all of the actual code changes we've made. We'll take the learnings, and then maybe we'll implement it a second time. But because we know what we did, we won't do all of that hacking around, renaming the files and moving stuff and what have you. So it's a nice way of keeping your sort of main product history sane later down the line when you do have to kind of go back and read down, you're trying to follow renames and what have you. So it's a good way of kind of like keeping that out of the way, but keeping the knowledge that you get at the end. There is a, kind of thought I'd put something in about shelving, because it feels like that's kind of, it's similar-ish kind of, it's sort of along the same idea of feature branch, but whereas over time we're sort of getting away from the idea of having long-lived branches, shelving is kind of very short-lived branches. Sometimes they're just used by tooling like TFS to do gated check-ins, which we'll kind of come to in a bit. But again, it is a way of effectively putting change to one side. There's context switching involved in this kind of thing. Certainly many years ago when you had, before hard disks were quite as big as they are now, it might have been easier to do an SVN, check out SVN switch to another branch, shelve your change, or with Git, rather than pulling down a whole new copy of the repo. If you've got a big Git repo, they could take forever to clone, to work in different workspaces. Stuff is plentiful now, it's less so. It's possibly more about using it within tooling and automation rather than about code reviews, or which is another sort of potential way, trying to keep a code review. But effectively, you're still pushing it to one side, and this period of time could still be days, weeks, or whatever. So I suppose the thing is that don't be lured into thinking shelving is temporary, because effectively temporary could still be quite a long period of time. I remember somebody who had something shelved for about 6 months, and it kind of like felt that was, calling it shelving still felt a bit disingenuous, because it was, it was branch. So I guess to kind of sort of summarize that, stable works kind of happen out here, unstable works kind of happening down here on our kind of feature and sort of releasey branches. And one of the reactions to this big bang merge that we happen at the end is trying to get away from the idea that we store all of our merge data up until this point, is then to start effectively merging, obviously a little bit sooner. Fairly obvious, really. Integrate a little bit more frequently, and then basically we're storing kind of less pain for this. More frequently could be weeks, days, hours, minutes. I mean, that's kind of thing. But ultimately, the however long we leave it to this point, that's still effectively going to be a problem. So, taking strategic points. And there's still problems with the changes that are going on around it and how we reconcile them, particularly when we talk about refactoring in a bit. So if we come back to kind of our slide with mention of Google, and again, thinking back to the beginning, 20 years ago when we didn't have branching, how do we deal with the fact that we didn't have branching? We just tread a bit more carefully. Well, okay, there was 2 approaches to it. One of them is you made all your changes on your local machine. You really hoped you didn't lose your hard disk. Windows didn't corrupt your hard disk or whatever. And then again, at the end, you might shove your changes kind of in at the end. The other way to deal with it, though, was to think about breaking the work down into smaller units of work so that we could kind of deliver a little bit more bits of functionality in a more kind of incremental fashion, which hopefully is what this conveyed. Is we've got 1A, effectively feature 1 is split across a number of commits. So there's a little bit here, and there's a little bit here, and there's a little bit here. So this, for instance, might be a refactoring, because by definition, a refactoring has no observable change. There's no reason why I can't do it here. Go into production, no problem. Maybe 1B is about the addition of a new feature. Again, if it's a feature the user can't reach or can't get to, I can deliver that code into production now. I don't have to worry about it. And then at the end, kind of C, that's the point at which we finish off that little bit. But to do this kind of like discipline means you need to adopt some way of turning that functionality on and off, and that's what feature toggles is all about. And that can be done in different ways. So it could be if-defs in code, or they could be rem. You could rem out something in a batch file. You could have command line switches which don't appear in the usage that you can silently know about. Config changes, any file changes. You can add parameters into the URLs on requests. Many, many different ways of effectively causing a piece of functionality to turn on and do so. Having them as a compile time thing makes testing, automated testing, a lot harder, whereas having them turned on in code allows you to obviously test both code paths, the old and new. It might even allow you to have variations, multiple variations of that. And then that leads to the idea of A/B testing as well, which is actually why don't 10% of our users go one way and we'll direct the other 90% of the users on the old one. So it kind of opens a lot of scope for learning about the feature earlier on in that product, rather than waiting to the end and then kind of like throwing the feature at them and then going, did it work? Does it, do they like it? Maybe sort of doing it piecemeal. It does involve quite a lot of discipline, because obviously you are, this is a live fire exercise. We have code that's actually going out into production, so it involves a lot of discipline. It also means that at the end of it, if you decide to switch the feature on, whether you decide to switch the feature off, there's almost certainly a cleanup task. So your product backlog, You know, when that feature's delivered, you still need a task of that backlog to go around and unwind the stuff, throw away the dead code, unwind any switches that you've added and kind of clean up after yourself. So even though you're here, there's still other work that kind of needs to be folded in, because otherwise you're obviously just going to accrete more and more dead code and add to complexity. So you have to be, you know, there has to be a lot of sort of cleanliness and hygiene stuff that goes around that. I will learn in a minute not to triple that. So, again, if we think about that as sort of the kind of like the no branching thing, then what's kind of come out, taking that idea and then sort of trying to look at it in a different way is to say, you know, how can we, rather than our people having to deal with the issue, can't we just throw hardware and throw tooling at the problem and make it go away that way instead? And so there's this sort of, these idea of sort of gatekeeper workflows has kind of sprung up, Gitflow probably being the most kind of common way of doing this. And this is about saying, well, the thing we value most is effectively our development branch. So how do we stop people breaking the build? How do we make sure things are clean? Well, let's not let anybody commit to it. Let's keep people away. Let's you know, keep Alice and Bob, give them their own feature branch. They'll work quite happily on those, and then there'll be a point at which that change will kind of make itself, there's a point at which it will, we need to take that change. And that could be in the case of an automated workflow. It might just be a case of the tests will pass. So effectively at say point B, Alice will take a change, a tool will effectively merge the stable point into there, try and do a build, run all the tests. If everything's green, great. We'll take that change into our main line effectively, and then that can then go out to other people. So the problem we saw with all of the with people storing up merge debt, that goes away by having a tool again automatically merging points into our branch. So that's kind of like a tool hood. If it's not automatic, then perhaps it's about people who are used to using things like Gerrit, I think, where effectively there's more review, that kind of process. People need to check things over, talk things. Then that's a kind of a more manual approach, but still the same, the idea of keeping people away from this kind of branch. As an extreme example of, I guess, of the kind of the cargo cult things, I visited a company where this was almost a kind of a literal representation of their setup, apart from the fact that they weren't Alice and Bob. There were two other people. So there were two people. This person was the front-end developer. This person was a back-end developer. They didn't even work on the same code, because this person worked in C#, this person did all the front-end in JavaScript. And yet, they still chose to use Gitflow because they thought that that would buy them. So effectively, they would never have a merge conflict, ever, because they weren't even working on the same code base. Well, maybe they might get one on a build script, but there is no way they would ever have any conflicts within that. But effectively, they still kind of worked in this kind of way because it's the way that everybody kind of like works now. You know, this is a big team thing, or maybe it's about maturity of people. It's not about that. And more recently, this has kind of come under fire from the perspective of, the problem with tooling is tooling gives people the opportunity not to talk. It's kind of like, if I don't have this person over here, I'll let the tool deal with it. I can sit there in my little bubble, I will take their code. If you've broken something, kind of like let them fix it. And one of the things that kind of the no branching approach of pushing, it actually forces people together, whereas potentially this could let them drift apart. So you need to have other checks and balances in play to ensure that people are playing nicely together and still talking about it. We still have the same fundamental problem of, are we actually building the right thing? But it's a useful thing to have in some circumstances. And now we have kind of distributed version control systems, not just one single SVN repo. We've got to think about forking, and forking is effectively just another form of branching. But it's a sort of form of branching which is now kind of a bit more extreme. The round trip, the idea of pull requests again, is kind of, you know, forcing somebody to work as far away from you, keeping them out of the way, whilst you kind of carry on, kind of building yourself a bit of protection. But maybe, if you're doing sort of working that way, there's an element of giving people, you might use that as a way of getting people to try stuff out. When they produce pull requests, maybe that are of a high enough quality, maybe you then grant them direct access to the repo and they can kind of work directly. So it's got some other ways of in a far less trusting environment, like a big open source project. It's another way of sort of getting a feel for how people are working and bringing stuff together. One classic example, though, of there's often maybe an assumption that the reason we're forking is because we're actually going to go off in two different directions. Anybody who wants to know, anybody who follows the sort of the Node stuff with IOJS and Node.js, where they effectively departed for reasons because they felt they had artistic differences. They kind of went off and then all of a sudden found themselves not long after having to come back together again, and then of course having to reconcile changes where they'd diverged by quite some way, and then having to reconcile that. So, forks aren't always going to be totally a throwaway thing. Sometimes there is potentially stuff to be gained out of that. So that's something to bear in mind. So branching is a technique for managing risk, but it's not the only way to do it, funnily enough. So kind of for the last bit, or for this sort of third part, I want to look at some of the other stuff that effectively we can do or around software development that hopefully allows us to maybe change our mindset slightly, or maybe think about other approaches that we might do. So I think the first thing is this notion of always be ready to ship, which kind of, I suppose, post kind of 2000, I didn't really know anything about Agile and stuff, but I'd kind of heard about this idea of I was working in a front office environment in a financial place, and there's certainly time to market was quite a big sort of thing. But it felt there was like a tension though between sort of that time to market and then also actually wanting to do a decent engineering job, and how we kind of dealt with that. And this kind of this idea though of sort of being ready to ship sort of brought in a new kind of like mindset about, rather than having a project where you effectively left the car in pieces for 6 months and you messed around with this and played around with that and bored new pistons and all that kind of stuff, and then eventually 6 months later you sort of like put it all back together again and went, kind of, does it still work? Does it still deliver what we want? Thinking about having that kind of mentality versus saying, well, actually, I don't know if you've ever seen the GIF, I wish I got it now. There's some people who change the wheels on a car whilst the car is moving, which is a fantastic YouTube video where the guy kind of puts it up on its side, and then people climb out the car, and as this car's driving along, they take the wheels off and swap them over, and then put them back on again, the car goes. It's amazing kind of feat, but that's actually the kind of thing that we're being asked to do now. We're being asked to kind of deliver functionality quicker and trying to exploit the opportunity, to reduce the opportunity risk by delivering functionality in a more kind of incremental way. So having a mindset, having to think about how you make a change in such a way that you can deliver little bits of functionality, bits of value. So a classic example is refactoring might be seen as quite a bland, is a little piece of work that might not have any specific kind of business value or no direct kind of business value, but effectively can kind of open doors or make changes, get that out kind of into production as soon as possible. Other bits of work that you have, breaking features down, maybe you can kind of get a happy path in, the customers can play with that, and it's got caveats to it, but effectively one of the things that came from this is this idea that customer feedback was actually more important in many cases than a desire to kind of like tidy up after ourselves and dot all the I's and cross the T's and make sure that the code was nice and clean. That sometimes, it's okay to kind of leave the tools on the floor of the garage whilst you're kind of like just checking sort of stuff out. Because if you're going to open it back up, if the customer comes back and it turns out it's not quite right, maybe you've got to make some changes, then you haven't kind of wasted time. So it feels like there's a sort of a slight dichotomy there between the waste that you kind of maybe create to keep the world in sync or to allow features to work versus sort of the potential waste you get from constantly tidying up after yourself to a degree, and yet actually it turns out you're going to open the thing, patient back up and do a little bit more work and that kind of thing. There's a balancing act between those things, but with it comes an ability to react and to changes much faster. And I guess that's kind of like goes hand in hand as we kind of think about agile software practices. This idea of the only way to be in a position to develop, to sort of be in a shippable state, is to kind of deliver much smaller bits of functionality. You know, instead of thinking about features in a big, start thinking about very small, fine-grained tasks that we can kind of like deliver into to things quickly. Yeah, so something that you classically get in enterprise organizations, there are things that work against kind of doing this. So again, the change request board or the change control board, this is a classic kind of organizational process that kind of almost like goes against this, because it's all about them trying to deal with risk in a different kind of way. And so there are probably some organizational issues around obviously trying to get that into a position of delivering smaller kind of bits of functionality. But there's a lot to be kind of gained from it. So naturally, automation plays a massive part within this. Certainly, obviously, within the things like Git flow and stuff, being able to having big tooling to run tests and build code in big systems. But we don't always have to think about automation at kind of like a big thing with big farms of servers and stuff. Even like simple little scripts and stuff. I think of, when I talk about automation, I'm talking about things kind of on the small things you can run on your machine. There was a recent tweet about, instead of needing like a big cluster, what you probably just need is a machine with 256 gigs of RAM. There are sort of smaller things, there are things that you can do kind of on your own machine and stuff that you can run. And so automation is more about, less maybe about economies of scale, and more about reliably and deterministically being able to run stuff. So run test suites, deployments, things like that. Scripting everything to make it so easy that actually it's more of a burden not to do it than to kind of doing it. And then developers kind of feel more inclined, and testers and stuff. It makes their job easier. And then it takes away the mundane, the repetitive. Then you stop ending up with problems caused by the fact that people follow different processes. Humans are notoriously bad at doing repetitive tasks, whereas computers are really good at them. So we should let them do that bit, and then we should focus on the stuff that's kind of that requires more cognitive load from us. So exploratory testing, that kind of thing. So yeah, sort of automation, about making it easy for those things to happen. And then a natural fallout from being able to do that even on your own machine is that then it becomes easy to then often to parallelize, and then you get your economies of scale that kind of come out like that. But again, that sort of is another sort of mentality that's kind of come about, is this idea that continuous integration means I'm running a Jenkins server. So again, I've seen a place where they run a big Jenkins server, but they actually commit their code onto separate feature branches, and the Jenkins CI server builds and runs those branches, but the code actually isn't integrated until right at the very end, 3 months later. That's not continuous integration, that's just using Jenkins to build code. Continuous integration is more of a philosophy, it's more philosophical thing around collaboration between people. It's about resolving conflict sooner. It's about you making a change and a co-worker making a change at the same time, or in conflict. And maybe that is it's not just a simple kind of like typo. The fact that you spaced your braces or whatever differently. It actually might be a design issue. There might be semantic problems involved in it. So it's about resolving those as soon as possible. And there's a consequence of that, reducing waste that happens later down the line, trying to understand some weird stuff that happened, or people who are then disrupted from it. So continuous integration is more about close collaboration between people. So naturally, automated test suites. We saw at the bottom of that tweet from Jez Humble that test cases is a big, is a big part of probably what we rely on. How do we gain that confidence in the product that we're building? And that will be often through the case of automated suites. There's still manual, some exploratory testing within. Now, I could have put the picture of the testing pyramid up. That's kind of like a real popular thing that people use, where you have your nice big barrage of unit tests and then some little integration tests in the middle and then a few little end-to-end tests. Stuff. But the landscape's kind of been changing recently as we sort of stop building monstrous, great kind of like monoliths where trying to test small components, where effectively end-to-end testing would be impossible anyway. As we start to build microservices and smaller, more focused components, the need to perhaps do testing at a unit level, or at least to keep those around, is kind of like diminishing. And so I sort of, one of the great things in the XP book is he never talks about unit testing and integration testing, but he only talks about programmers tests and customer tests. And I really like this tweet, and although I don't agree, you know, if you substitute end-to-end to acceptance test, or then I think this is kind of a nice way of looking at it. It's about saying, first of all, being able to answer, is what I've just done, does that work how I expect it to? Then being able to ask about the outside world, is that working? But obviously, most importantly of all, is actually, have I delivered what the customer wanted? And then there's a thing that comes around with, well, actually, do I keep the tests, the unit tests around that? Because maybe the bit that the customer tests that I write at the end, if I work in an outside-in fashion where I start with a failing acceptance test and then maybe do some unit tests, and then I might unwind the stack, and if I'm talking to the database, I might put some automated integration tests, and they come right back out to the end, and that succeeds. Maybe there's enough coverage at an acceptance test level that the unit tests don't actually do anything, and now all I'm doing is wasting time running a whole load of stuff that doesn't really tell me anything. Because this is about triangulation. It's about being able to know. Unit tests kind of came out of when you've got a big system, when something failed, knowing where to even start looking, which you can't do in a big system. But as we build smaller things, smaller little products, smaller services, it's often easier to get a feel for where they are, because some of the other practices means we know more about the system. So the value of that. Jim Copeland published something quite recently called Why Most Unit Tests Are Waste, and he's kind of alluding to a similar thing. There's a bit of, I think, a battle between him and Google on whether, you know, where that kind of like value sits. But I think, you know, you think about it as sort of programming stuff, you know, me doing what I do, and then do I deliver what I need to the customers being a different thing. So, but a significant amount of coverage and tests is effectively going to buy you that, coupled with obviously automation. That will give you probably your biggest confidence boost about where things are. And obviously outside of the, does it actually work, there's also the trying to test performance. Does it still meet our SLAs, which is quite possibly a thing as well. And then being able to build environments out to make that happen. So one particular practice which really butts up against branching choices is refactoring. If you're in a kind of an XP, if you work in an XP environment, refactoring is a massive part of what you do. People talk about mercilessly refactoring or relentlessly refactoring. It's a continual thing. And unfortunately, we code a lot of our design, our physical structure is coded. So this is Mr. Lakos will tell you about, is the fact that we use, our namespaces are reflected in the file system. Our class names are reflected in those. So when you start moving things around and going, oh, actually, it'd be a lot better if I took this bit of code and I stuck it in that namespace and I reorganized that. As you start doing that, that creates a huge amount of tension, certainly in old-fashioned tools that work around files and match on file names, things like Subversion stuff. Trying to do refactoring that involves moving code around, not just even within methods, but lifting stuff out, can create a lot of tension. And if you've got long-lived feature branches, you've got any refactoring going on, then you effectively, your merge is the merge from hell, because first of all, you've got to even work out where the hell your change even exists, in what file, what folder, before you've even worked out how to get your bit of code in there. So there's using a tool that doesn't support those kind of file system operations is going to make refactoring naturally hard. So we need to do stuff to, you know, if you're going to embrace it, and it is something that really should be embraced, if you want a malleable code system that is going to involve and you're going to be able to deliver, you've got to embrace this. And that might mean you need to reconsider the approach you have to it. But as I said, a feature branch may well involve a heavy amount of refactoring, but you might throw it away. That's fine, but just you might soon. For all its ills, ClearCase, which has so many other problems, actually one of the things it did quite well early in its days was its ability to do, it did directory versioning, which I think bizarre, I think was another version control system that specifically versioned directories, which meant that when you move things around, it knew where you'd move things to directly, and as a consequence, if you did do this kind of refactoring, it didn't necessarily impact people. Git takes a different approach with it. It looks at content and where it goes, so it's kind of smart. But again, you know, modern tool, you have to look at using modern tooling if you want to embrace refactoring in its kind of like most severe, you know, extreme form. Particularly as we sort of start thinking about architectural level refactorings, where you might even start lifting components out and putting them other repositories and that kind of stuff. So we start breaking up monoliths. It's only going to become more and more important how we do this. Okay. Another practice, which again comes from kind of the XP world, is pair programming. And I mean, you know, why stop at 2 people? Why not have 3, 4, 5 people? You know, mobbing on particular thing. On Friday, we had a socket error on some piece of code, and there's 5 of us standing around, spent the entire day standing around one screen, kind of like trying to solve kind of, you know, one particular kind of race and stuff. And one of the big things that comes out of pairing is apart from that kind of, you know, there's an element of increased quality because of the actual cases that you deal with, the code that you write, but also it's a great way of sharing code and you know, by swapping around partners. And once you get a more kind of like shared code ownership, you then become, and there's an element of kind of like honesty, sort of keeping people honest within it. Once you have sort of that level of collaboration, you kind of less sort of worry about pushing people to one side. So, you know, rather than pushing somebody out, a junior or an intern, instead of trying to keep them to one side because you feel uncomfortable with what they do, pair them with somebody who's experienced so that they get to learn, but then they get that really warm, fuzzy feeling of having code go out to live straight away into production, because that will boost them rather than them feeling like a pariah who's kind of like kept out of the way. So pairing's another way of dealing with that tension between people and you know, the changes and stuff that they're making. Woody Zorl has a really good talk on mobbing where they do it with 5 or 6 people constantly. There's like just one screen and one keyboard and like 5 of them always working on the whole thing. And they found that their velocity went, you know, up higher when you'd think that, you know, there'd be economies of or limits to it, but he seems to work, you know, find it works quite well, even at big scale. And I guess one of the last things is pushing sort of to the far end of the pipeline. So we're going to do some testing. I think I've heard it say that any advanced sort of monitoring is indistinguishable from testing. The stuff that Rachel Davis and the Unruly team are doing around, you know, monitoring and stuff, is sort of beginning to kind of like blur the lines a bit. That need to kind of reduce the opportunity risk and get stuff out sooner, but then maybe putting that out into a sort of to a smaller audience, but then being able to detect what's going on and to be able to react to that, so that when you spot problems, that you know about it before your customers do. You know, there's advantages to that, but that means getting sort of changes out sooner. But you can maybe take a slightly riskier path to that if you know that at the far end of it, you're watching it like a hawk. You've got a lot of statistics and backing around what you do, how the database is performing, how, you know, services are performing and stuff. So monitoring, having a good degree of monitoring and being able to sort of slice and dice and understand what's happening in your system, you know, buys you, you know, an ability to deliver much quicker. 2 books. I mentioned this book. This is really old. I mean, this lists version control systems, and Subversion isn't even in it, which sort of tells you how old it is. I think CVS was the in thing when this was kind of like written. But even so, not only cheap. I mean, you know, I don't buy books that are expensive, but it was kind of like a cheap thing. But it has an interesting take on the idea about constraints and policies and reasons why you might choose to deliver. And it takes into the people that wrote this have obviously worked in way more environments than I've been in. So I haven't worked in an embedded arena, so I don't know what it's like to deliver, you know, a physical product, you know, that you can't update. And so, you know, that takes into account those kind of environments. It's very easy for the webby people who have full control over their stack maybe to sort of, you know, talk about branching in one thing, but there are other people, you know, probably develop pacemakers
who have just a completely different set of constraints, and it's a whole different world. But anyway, it covers quite a few sort of things, but it is quite an old book, so just from a kind of a description. And then obviously more recently, Continuous Delivery book is kind of quite popular, and their sort of take around pipelines, and again, they discuss sort of branching and techniques, dealing with that kind of conflict and stuff quite well in sort of chapters around building and branching and stuff. So it's quite a thick book, but can't get that on cheaply. It's too new, unfortunately. So I guess in summary, talk wrapped up in 30 seconds. Branching can be used to manage some risks, but I think there are better ways to do it sometimes in some contexts. Lots of caveats. Lots of caveats in there, of course. It wouldn't be fair to say I know about what everybody's doing.